What up, your boy C Rizzy coming at you with Unit 7, Lesson 3, Proving Triangles Similar. Our essential question is how do you show two triangles are similar? And our objective is to use angle-angle similarity postulate and the side-angle-side similarity and the side-side-side similarity theorems. Our essential understanding is you can show that two triangles are similar when you know the relationships between only two or three pairs of corresponding parts. And sometimes you can use similar triangles to find lengths that cannot be measured easily using a ruler or other measuring devices. So the first postulate we're talking about is angle-angle similarity postulate, which states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. The reason this is angle-angle and not angle-angle-angle, if we remember about third angles theorem that says we only need two to be able to prove the third. So if I got two angles are congruent to each other, then I know automatically the triangles have to be similar. Then there's side-angle-side similarity, which is just like side-angle-side congruency, except I'm not trying to prove that the two sides in the included angle, I'm not trying to prove that the sides are congruent, but that the sides are proportional to one another. And lastly, side-side-side similarity states that if all the sides are proportional in a triangle, or if all the corresponding sides of two triangles are proportional, then the triangles are similar. Okay, so let's verify this. So let's say I was given two triangles here, UST and VXW, and I want to figure out if they're similar. So you don't have any angles that are congruent to each other, so you figure out, well, how do I know which sides correspond to one another? So the trick is that the shortest sides will always be proportional to each other. So 6 and 9 are my shortest sides, so that's how I find my scale factor from them. The longest sides will always be proportional to each other, and then obviously the remaining sides will be proportional to one another. So in this problem, you see they all come out to a scale factor of 2 to 3. So these triangles would be similar to one another. Alright, so let's do this. Number 1. Are the triangles similar, yes or no? Alright, so I haven't been given any sides, so it's got to be angle-angle if it's going to be anything. I know that angle is 35 degrees because it's vertical to the other 35-degree angle. And then the other angle has to be whatever 180 minus 135 is, which is 45. So this angle has to be 45. So number 1, yes, by angle-angle similarity. And I'm going to call this triangle AZE is similar to triangle, and A will be congruent to R, Z is congruent to B, and then E is congruent to itself. Okay, number 2. So I've been given the three sides, so I got to figure out if they're proportional to one another. So let's take the shortest sides of ABC, which is 2, and the shortest side of DFE is 3. So 2 over 3 has to equal the longest, so that's 4 over 6, which has to equal 3 over 4.5. So 2 divided by 3 is 0.666. 4 divided by 6 is 0.666. And 3 divided by 4.5 is 0.666. Therefore, yes, by side-side-side similarity, and triangle, say ABC, is similar to triangle. So what was 2 is parallel to 3, so we're going to say FED is what it's similar to. And the last one, number 3, we're going to have to do side angle side. So I've got the congruent angles. And again, shortest to shortest. So 12 would have to be proportional to 15. And 16 would have to be to 20. And 12 divided by 15 is 0.8. 16 divided by 20 is, I'm assuming, 0.8, which it is. So again, yes, by side angle side similarity. Triangle, we'll say UGA is similar to triangle BEF. Alright, that's all from me.